Stop scrolling for 1 second and hit like right now, because this planet should not exist, and yet it does. Imagine astronomers staring at their data and quietly realizing that something in the universe just broke their rules. Not a theory, not a simulation, a real planet, 635 light-years away, calmly orbiting its star as if nothing is wrong. This world is called Kepler-22b, and from the very first moment it appeared in the data, scientists knew it was dangerous to our understanding of reality. Dangerous not because it is hostile, but because it fits too well where it shouldn't fit at all. Kepler-22b was discovered in 2011 by NASA's Kepler Space Telescope using the transit method, watching for tiny dips in starlight as planets pass in front of their stars. At first, it looked ordinary. Then the measurements came in. Its orbit was almost perfectly circular. Its distance from its star placed it right inside the habitable zone. And its star, a yellow dwarf like our Sun, was slightly dimmer, slightly calmer, slightly more stable. That single detail changed everything, because a planet like Kepler-22b, more than twice Earth's size, should be a gas-covered mini-Neptune. It should be crushing, toxic, and lifeless. Instead, the numbers suggested something else: temperatures that could allow liquid water, long-term orbital stability measured not in millions but billions of years, a climate that should not survive on a super-Earth, yet possibly has. If this planet were orbiting our Sun, it would sit between Earth and Venus, a region that produces hellish worlds. But around Kepler-22, that same distance becomes just right. That contradiction is the heart of the mystery. And here's the part most people miss. Kepler-22b was not discovered because scientists were looking for it. It revealed itself by accident, hiding in plain sight until the math exposed it. If that alone doesn't make you pause and question how many impossible worlds we've already missed, tap like again, because this story only gets stranger from here.
To understand why Kepler-22b is so unsettling, you have to picture what life on this world would actually be like. One of the biggest unknowns is whether the planet is tidally locked. If it is, one hemisphere would face the star forever, while the opposite side would never see daylight. That sounds catastrophic, but physics tells a more complicated story. On the bright side, constant starlight could heat massive oceans, driving powerful evaporation cycles. Thick cloud systems would likely form, reflecting excess heat and preventing runaway warming. Instead of burning, the surface could stabilize into a warm, humid environment with endless daylight. Life there would not experience days or nights, only time measured by storms, currents, and chemistry. Now imagine crossing to the dark side. Eternal night, no sunlight, surface temperatures falling toward freezing. But beneath the surface, heat from the planet's interior could keep oceans liquid. On Earth, entire ecosystems survive in total darkness around hydrothermal vents, feeding on chemistry instead of light. On Kepler-22b, those environments could exist on a planetary scale. Life there would glow, move slowly, and evolve senses we don't possess. But the most important region may be neither light nor dark. The terminator zone, the narrow ring between day and night, could be the most stable place on the entire planet. Temperatures here would remain moderate. Winds would flow continuously, distributing heat. Liquid water could persist without boiling or freezing. Many scientists believe that if complex life exists on Kepler-22b, this is where it would concentrate. But no matter where you stand on this planet, one force dominates everything: gravity. Kepler-22b's gravity could be several times stronger than Earth's. Walking would feel exhausting, falling would be deadly. Plants would grow short and dense, animals would be compact and muscular, and flight would be nearly impossible. Oceans, however, could soften gravity's grip, allowing large aquatic life to evolve. If this is already stretching your imagination, good, that's exactly why this planet matters. And if you're still with me at this point, hit like again, because we're about to confront the biggest obstacle of all. The cruel irony of Kepler-22b is that it may be one of the most promising worlds for life, and one of the most unreachable. At 635 light-years away, even our fastest spacecraft would take close to 1,000,000 years to arrive. The Parker Solar Probe, the fastest object ever built by humanity, reaches only a tiny fraction of the speed of light.
At that speed, civilization itself would rise and fall thousands of times before a probe ever arrived. Even future concepts like nuclear fusion propulsion or light sails would still require thousands of years. For now, Kepler-22b exists only through photons, equations, and imagination. But it is not alone. It belongs to a growing list of exoplanets that are rewriting the rules. Kepler-452b orbits an older Sun-like star, potentially giving life billions of extra years to develop. Kepler-186f is Earth-sized and sits quietly in the habitable zone of a red dwarf, possibly with stable seasons. Kepler-1649c receives nearly the same energy as Earth and was overlooked for years due to a simple data error. Kepler-442b ranks among the most Earth-like planets ever discovered by habitability metrics. Yet Kepler-22b stands apart because it breaks expectations at every level. It suggests that life does not require Earth's exact size, gravity, or rotation. It hints that the universe may favor diversity over familiarity. Worlds heavier than Earth, worlds covered by oceans, worlds with permanent day and night. And if life can adapt to those extremes, then the number of potentially living worlds in the galaxy may be far higher than we ever imagined. If this realization just shifted how you think about life beyond Earth, you know what to do. Tap like and stay with me, because the final part explains why this planet may permanently change science itself.
The future of Kepler-22b depends on one thing we don't yet have: its atmosphere. With telescopes like the James Webb Space Telescope, scientists hope to detect the chemical fingerprints of distant worlds: water vapor, carbon dioxide, methane, or oxygen. These gases could reveal whether Kepler-22b is a barren super-Earth, a global ocean world, or something even stranger. But the real impact of Kepler-22b goes far beyond a single discovery. It challenges the way we search for life itself. For decades, astronomers focused on finding Earth's twin: same size, same star, same orbit. Kepler-22b suggests that strategy may be too narrow. Life may not need a perfect Earth copy. It may only need stability, energy, chemistry, and time. And those conditions may exist on worlds we once dismissed as impossible. If Kepler-22b can exist, then countless other forbidden planets may exist as well, quietly orbiting distant stars, waiting for us to notice them. Worlds with stronger gravity, deeper oceans, thicker atmospheres, and forms of life shaped by conditions far more extreme than our own. Kepler-22b may never host civilizations, forests, or cities, but it may host something even more important: proof that life is adaptable beyond our imagination, proof that the universe does not care about our expectations. And that realization changes everything. Because once you accept that life can thrive on worlds like this, the question is no longer, are we alone? The question becomes, how common is life really? If this video made you look at the universe differently, hit like one last time and remember this planet, the alien world that shouldn't exist, and yet does.